Salut.
Salut Louis.
Salut.
On se demandait ce midi, il y a un petit jeune qui s'appelle Titouan qui est motivé à aider Tournesol. Peut-être qu'on pourrait lui enseigner la technique des streams et qui l'aiderait à l'organisation des Tournesol Talk.
Ah ouais, très volontiers.
Ouais, parce qu'il y a aussi tout ce qui est communication en amont sur Discord, sur les réseaux sociaux. Et du coup, si quelqu'un s'en charge et qui n'est pas toi, c'est mieux.
Ouais, très volontiers. Je pourrais le contacter en ton nom, Louis?
Ouais, pourquoi pas. Enfin, je vais lui envoyer un message tout de suite, là, comme ça, on verra ça, juste pour le prévenir et voir son avis si c'est quelque chose qui pourrait l'intéresser.
Ça marche, merci.
Okay, donc, vous voyez, on est déjà en train de streamer, j'ai checké, ça marche.
Cool.
Donc, on est en live devant tout le monde.
Ouais. Je n'ai pas regardé le nombre de personnes qu'il y avait, mais il y a une personne qui est en train de regarder sur YouTube, et j'imagine que c'est moi. C'est la folie. Alors que sur Twitch, il me met 0 alors que je suis en train de regarder. Donc, cool. Je crois qu'après sur YouTube, il y a moyen de couper aussi le début. Et il faudrait que... Parce qu'il y a clairement des outils pour couper. Comme ça, si on veut envoyer cette vidéo... Parce que du coup, je vais quand même pas mal faire le point, enfin, non seulement sur les algorithmes qui sont aujourd'hui, mais sur questions de recherche à venir.
Ouais, du coup, c'est intéressant, effectivement.
C'est en plein milieu. Attends, là, vous voyez mon écran là?
Je le vois plus, mais je sais pas pourquoi j'ai été déconnecté et reconnecté.
Moi non plus, je ne vois plus, c'est moi.
Ok, je pense que quand j'ai mis en plein écran, en fait, ça a arrêté de partager.
C'est bon.
Ok, c'est un peu embêtant si Julien est déconnecté.
Ouais, c'est là il m'a redéconnecté une deuxième fois, je sais pas pourquoi. Du coup, à chaque fois, ça me fait stopper le stream quelques instants.
Parce que une possibilité à venir, ça serait d'avoir un JT juste avec le speaker et peut-être Julien, enfin quelques personnes pour l'introduire, quoi, et pour l'aider à prendre des questions et tout ça, côté un peu technique, et puis après avoir la plupart des gens qui regardent plus sur YouTube ou autre. Et moi, on n'est pas si nombreux, donc c'est un peu comme si c'était une excuse valable des JT.
Effectivement.
Sinon, il y a aussi, il faudra qu'on essaie Infomaniac, hein, depuis le temps qu'on a le truc. Oui, pas. Oh, Thomas.
Salut, salut.
Salut.
Salut Thomas.
Et bien.
Tu veux commencer franchement.
On peut, ouais, peut-être, je pense, 8h20. Ça te va, je lance maintenant ou
Ouais.
Ouais, ok. Start recording. So, hello everyone. It's a pleasure to start again the Tournesol talks after a break this summer. So, just a quick reminder, the goal of the talks is to talk generally about AI safety or the information crisis that we have today, but also to create a community related to Tournesol. And today it's a pleasure to have Lei and Nguyên Hoang himself talking about the recent progress that have been done research-wise and not only on Tournesol. Lei, we are listening.
Yeah, thank you for the introduction. So, hello everybody. So today I want to review the recent work that we've deployed actually on Tournesol last summer, but also to sketch out the future work for Tournesol. And I guess I also mean to say that if you are a researcher in mathematics, computer science, and other fields as well, especially like psychology, philosophy, sociology, then or law, then there's a lot of connections going on with a lot of different fields, and a lot of the upcoming questions will require a lot of different expertise. So if you are interested in the research questions that I'm going to discuss, well, feel free to get in touch with the Tournesol team, and we'd be more than happy to plan collaborations, research collaborations with you. Another thing I mean to say before starting is that this is really a collaborative work. So, like we designing a collaborative platform, but in order to design the collaborative platform, we're also doing a lot of collaborative research. So this is what I'm presenting today is really the result of joint work with a lot of different people. So I've put a few names here of people who made a significant contributions more to the research side of Tournesol. And also a list of names of people who we are in talk with to further the frontier of research on algorithmic governance more generally. So much of the talk will be mostly these two papers. There'll be a bit more than these two papers, but these are papers that are currently under submission, but they are available on arXiv. So if you want to take the time to really dig into what we've been doing, well, these are the references you should look at, especially the one on the left. What I'm going to talk about today is can be sort of like not really summarized, but like mapped out with this what we call the pipeline. So this is kind of like the pipeline of how we plan to do like collaborative governance. So this is extremely simplified and extremely but it's already quite complicated. So I'm not going to explain it right away. We'll go through different steps, and at the end I'll come back to this, and hopefully you'll have a better view of what are the different components of Tournesol, the pipeline of Tournesol to have this governance. Well, the first aspect is trust. So because we want to be so-called permissionless, so the idea of permissionless is that anyone can create an account on the platform. We don't have a predefined set of participants, so because we don't have a way to list all of the humans, we have a more open system where people can create their own account. But of course, as soon as you have this permissionless system, then there's this issue of trust that arises. In particular, I think in many platforms, online platforms, the issue of fake accounts is like growing more and more, especially with ChatGPT and so on. And so handling trust is a fundamental question for any kind of platform out there. Yeah, I guess one thing I'm going to stress is that all of the issues that we have is not specific to Tournesol. So how do we go about this on Tournesol? Well, we first have a first layer of protection, which is based on email domains. So we have a manually curated list of trustworthy domains. And essentially, if you have an email that is from one of these domains, then it's going to be given some trust. So the key idea behind this is that we believe that many of these email domains it's hard to create a lot of fake accounts with these emails. So it's very easy for anyone to create an email at gmail.com, but it's very hard to have an address that finishes in a valid email domain address that finishes in, for instance, anyone on the right here. So, for instance, ACX Marseille FR. And so this gives us some protection, and that's why accounts that are created with these emails are considered pre-trusted. They have some trust just because of the email. And then our goal is to propagate the trust by having a vouch system. So we have a deployed vouch system where if you click on the top right when you're logged in, then you have this vouch option. And using this vouch option, you can list other users on Tournesol that you would want to vouch. And by vouching, what we really mean is that a vouch, the other person, the vouchee, the person that I'm vouching for, should be a human and should be like using only one account, like really using one account on Tournesol and not more. So it's not just about filtering out bots. It's also about like guaranteeing that one person can only have one active account on Tournesol. So that's kind of the idea of the electoral card in democracy. So one person, one vote. Now, based on this, we kind of have this network of users where you have an arrow from one user to another if the first vouches for the latter. And we have some pre-trust based on email domains. And so then our idea is to propagate trust over this network. And we're using a novel algorithm to do this, which is called Lipschitz trust. So it's computed by this function called trust here in the paper. The idea of Lipschitz trust is kind of based on PageRank. It's a variant on PageRank. So if I go back to this slide, the idea of PageRank is like you randomly navigate through the network. So for instance, if you are like on the top left currently, you will randomly select one of the outgoing arrows and follow it. And then you just keep doing this. So if you ended up on either in Django, so on the bottom, on the top middle, then you would select again a random arrow and follow it. Now the issue with PageRank, if you just do it just like PageRank does, well, there are a few issues, but one of the issues is that there's a risk of concentration of power. If too many people vouch for the same individuals, which is something that if you think about it happens a lot on social media, then the person that gets a lot of vouches, that kind of an influencer, and it's like, like quantified sense, if you apply the PageRank to the social network using PageRank, then this influencer will have too much trust, like a lot more trust than anybody else. And that's a big issue, because if they get compromised at some point of things, then they will have too much power. And so one of the concern we had when designing this trust propagation is to limit the maximal influence of any individual in the network. Not only the influence in terms of voting rights, I'll get to voting rights later on, and so individual trust, but also in how much trust they can give to other people. So if you imagine that someone is malicious, then they could vouch for accounts that they created themselves or that they control, and like the vouches would amplify other accounts that they control themselves. Well, we had this security risk in mind when designing the trust propagation algorithm, and Lipschi Trust protects us against this. For one thing, like proposition one, well, it's kind of a trivial consequence of the way the algorithm is set up, but like the maximal trust of any individual is going to be at most 1. So that's the first proposition. It's by design, and the one is parameterizable, and it could be interesting to have something more than 1, especially if we're doing liquid democracy, and I'll get to this in a bit. But yeah, that's kind of a nice guarantee. And the other nice guarantee is that you cannot, like any individual cannot create too much trust to entities that are actually not trustworthy. And this is the theorem 1 here in our paper. It essentially says that the trust that would have been given without the vouchers of a node cannot be that different from the trust that would have been obtained if the node or the contributor in question did not vouch at all. So whether they vouch or not does not completely change the distribution of trust. So that's kind of the idea. And this is parameterizable again. You have a beta here that controls what is the maximal influence of any individual in terms of trust propagation, which is quite nice. And I believe that this kind of I believe this algorithm to be not tight, so that there's an improvement on this algorithm. But the kind of theorem that we have, I think, is the right kind of theorems in terms of secure trust propagation, which I think is quite an interesting advancement we had last summer. Another aspect of Tournesol is voting rights. So voting rights are not actually equal to trust. For one thing, we actually have guaranteed on Tournesol is that any contribution by any contributor will have an impact, will be counted, will have an effect. So actually, anyone is given some voting right. The trick we found to still protect ourselves is to only reduce the voting rights of individuals if there are too many people who are not sufficiently trusted who express themselves on the same video. Then their voting right on this video is going to be reduced, typically so that they're not too large and that they are still a minority. That's kind of the idea. More precisely, the way we're doing this is we first define this over-trust, which is like the total amount of voting right we're going to allow ourselves to give for when voting on one video. And this over-trust on a video is going to be related to the total trust of all the contributors to this video. All the persons who evaluated this video, you add up all of their trust, and then we allow an over-trust that is not too large compared to this trust. And this overtrust, so it's it's an affine function. So even if nobody trusted, no trusted individual scored the video, then you still have some voting rights that you allocate. And maybe I'll discuss why it's okay to have some voting rights, as long as they're not too large. But even if there are only malicious people voting on the video, we're still protected. And then here F is if there are many people who are trusted voting on the video, then we want the people who are not trusted to only represent a fraction of all of the voting rights. And so that's the fraction F here. That's defines this essentially. So once we computed the overtrust, so how much overtrust we allow ourselves on a video, on a given video, then essentially we give this overtrust to the people who are not sufficiently trusted. Now, I'm not going to go into all of the details of how we're doing this. It's not very complicated, but it's a bit long to explain. But essentially, we guarantee that on any video, we increase the voting rights of people who are not sufficiently trusted until we have an overtrust that is not acceptable for the platform. That's kind of the idea. Now, related to this question is a future work prime, which is integrating liquid democracy in Tournesol. I think this is an exciting challenge. There are so basically the idea of liquid democracy is that sometimes to another individual. And actually, one thing we can do on Tournesol quite easily would be to delegate to many other people. This would prevent overtrusting one individual. When you're delegating a vote, you can delegate to many people. But there are many challenges that come with actually implementing a liquid democracy that we're still figuring out. It's kind of ongoing work rather than really future work. Especially we have a philosopher, Mathieu Nyongo, and a researcher, Manon Revel, who did her PhD in computer science, but on liquid democracy stuff. And now she's a postdoc at Harvard in law. So there's a very nice pluridisciplinary approach here with multiple viewpoints. That's interesting. And I to me right now we're still at the brainstorming phase of really understanding what are the changes, the risks that may occur, and how do we address to make sure that liquid democracy is functioning in a satisfactory manner on Tournesol. For one thing, but we have made a few progress, I think, in our brainstorming so far. So one thing, for instance, is to distinguish two kinds of delegations. So there might be two different reasons why I would want to delegate my vote. On one hand, there's what I call activity delegation. So that's typically due to the fact that there are people on Tournesol that I'm somewhat, I trust. I don't maybe I trust my judgment over theirs on at least some videos. So I don't trust them more than I trust myself. But they are very active on Tournesol, and I trust them sufficiently to give them my voting rights on the videos that I did not have the time to evaluate myself. So this is called this is what we call activity delegation. So I'm not active enough on many videos, so I would like to delegate to those people who are complementary to me in terms of activity. What's nice is that there are too many videos in any case to judge on Tournesol, so I would still want to delegate some activity to people, even if they are less active than me, just because they are active on different videos than I am. And this is, I think, by opposition to expertise delegation, which is more related to what is sometimes known as a judgment deference. You defer your judgment to someone who you consider to have a better judgment than yourself. And this is for one thing, it's different in the sense that if I already evaluated the video, and then this guy that I trust more than myself in the evaluation of this video scores this video, then I would want my vote to be cancelled and to be replaced by the other person's vote. Like, this is really like a deferring judgment. Like, this is really the definition of this. So I would defer my judgment. So that's one thing that's different. The other thing that's, I think, very interesting is that it would be a very natural mechanism to identify and justify expertise. And there's a lot of philosophical debates about democracy versus epistocracy, where democracy, like one person, one vote, and epistocracy would be like giving more value to expertise. And I think on many topics like climate change, it seems like important, cybersecurity. And so, but the challenge of epistocracy usually is to justify the fact that you are like this expertise. How do you justify it in practice? And so that would be one way to go. Relatedly, I think I didn't put it, so I'm going to say it out loud. There's the question of the granularity of the expertise. Like I once made a video that called for the separation of expertise and make sure that an expert is an expert only in some topics, but not in all topics. And so there's the question of how do you define the granularity of expertise. And so one idea typically would be like to have an expertise delegation per video. Another idea would be by YouTube channels. Another idea would be by tag. So these are ongoing questions that we have in the implementation of liquid democracy. Another thing I think is important is due diligence. Whenever you're delegating your vote, I think it's important that you have some diligence over the persons you delegated your vote to. And in particular, I think it's related also to the expiration date on the delegation, which is also apparently a very classical problem in liquid democracy design. And so, and what's interesting is that we can use solutions on Tournesol, on the platform, to improve this due diligence. So typically one thing you can have in mind is if your delegate has an opinion that's very different from the community of Tournesol, then I think it would be nice if you were somehow notified of this and you would be asked to confirm, to reconfirm your delegation to your delegate. I think it's at least interesting for now to really think about this. I mean, in terms of actual implementation, there will also be the question of what kind of MVP or kind of first version of this liquid democracy could we easily deploy. But I think prior to this, it would be nice also to have a more fundamental thought about what would we want to be there for a good liquid democracy. A big challenge of liquid democracy, and this is something that both Manon and Mathieu called our attention on, is how do you have delegate discoverability? How do you find the delegates? How do you how do you build trust also in your delegate? I think it's somewhat related to the previous, but it's a big challenge in liquid democracy design. So I think it will involve in the long term making Tournesol a lot more social than it currently is, and to be able to see, for instance, who are the people who recommended that or that, who had a particular weird opinion on this or that. Maybe also it could, I mean, one thing that's related is like the ability to comment on videos. I think will be something interesting to ponder. It raises huge moderation issues. So how do we handle that as well? Maybe you can take inspiration from things like poll.is. Lots of questions about how to design this in the best possible way. A fourth point that has come up in our discussion is the problem of delegation biases. One thing is, for instance, the imposture syndrome. So some people do not trust themselves as much as they should, the other hand, there's the opposite, like some people trust themselves more than they should, arguably. So how do you deal with this? Another thing is, I think equally an issue, is like some people tend to be more, to attract more trust for wrong reasons, or appear more competent than they are. How do we identify and correct these kind of things? Can we use, for instance, Tournesol to highlight, for instance, to people that, well, for instance, maybe all your delegates are white men? I'm just saying this out loud. Like maybe these kind of notifications could be interesting to point out. Yeah, I think these are things that we could be thinking of. Yeah, relatedly, like incentivizing expert delegation, I think it would be extremely valuable from a sociological point of view, from an epistocratic point of view, if we can have this, use this system to identify experts in a way. Typically, an expert would ideally someone who is regarded as an expert by other experts. So this would correspond to demanding or asking people to identify people that they trust in terms of expertise, even though they themselves consider themselves as expert. So I think this could be, well, this is an interesting thing to ponder, and it raises all sorts of issues. I think many of these issues are really about interfaces that we design, but also like algorithms that we use to propose all of these things. Oh, I guess the last thing is like, I feel like, at least myself, I feel like I'm still like an early phase of all of these thoughts, in the sense that I'm still discovering new ideas regularly about liquid democracy. So I think this is, yeah, hopefully maybe we'll uncover ever more changes, important changes as we go. And I guess equally importantly, it would be nice to discuss with people who are more into these things and what kind of concerns arise in their minds with this. Okay, now we're going to move further. So once we trust different people, giving them voting rights, maybe you have some voting right transfers using liquid democracy. The next phase is getting people to vote on what the behavior of algorithms should be, for instance, and particularly on Tournesol's recommendation AI. And the way we go about this on Tournesol is by using comparisons. So we ask people to select content on YouTube and to tell us which one should be more recommended. And a recurrent theme on Tournesol, especially from our users, is should we use this comparison method, what justifies the comparisons, rather than direct assessments, as is more common in many platforms. You can think of YouTube with likes and dislikes, but also Amazon, Google Maps, and so on. I mean, so actually getting more and more in touch with a lab in EPFL, Matthias Groth Labs, especially through Oscar Vibo, who have done a lot of work on this question and are currently investigating likes, like the direct assessments as opposed to comparison-based judgments. Essentially, it's thanks to their work that we've decided to go through comparisons. We believe that this yields more thoughtful judgments that are more accurate in a sense, that are reduced noise, that allow multiple comparisons. So this also allows to mitigate noise in users' inputs. And then the challenge is, if you do comparisons like this, how do you transform these comparisons into scores? Because we still want scores that are easier to handle for different reasons. When giving the quality of a video directly on Tournesol, and also when select recommended. So the problem of transforming, but need for smooth comparisons, like it's been widely studied for binary comparisons. So you can think of this is like typically you have to select one of two options. This happens a lot on the internet whenever you you search something on Google, and you have multiple answers, and you have to select one of the answers. So that's like one choice out of a few. But somehow this is also something used a lot. Theory model GPT, so that was the paper on the right. This is a work that was mostly led by Julien, who did a very fantastic work, and he also gave the previous Tournesol talk about this. So if you want to know more about this, I refer you to the previous Tournesol talk. But what's nice about this kind of model is that we've proved nice properties, including, for instance, monotonicity, which is a clearly desirable property, which says that if you change your mind and you actually say that A is much better than B, as opposed to before where you said that only A is slightly better than B, then the score of A should increase. That's the intuition. And we proved that with our models, this can be, this is guaranteed. We also have some resilience property. So there are many open questions with this way of learning, like individual. Like I think the more general problem is really preference elicitation. So how do you get out of humans their preferences? And it's actually very hard, and especially like humans that are not really keen on doing mathematics to do this. How do you have a simple interface that elicits their preferences in a way that is efficient and that allows to construct a model of their preferences that is fair and that they can check and so on. So this raises like fundamental questions. So like classically, the Bradley theory model is linked to a more, I guess, psychological model called the Thurston's model. And it would be interesting to find out, to understand better to what extent we can justify GPT or propose other algorithms that have a good Thorstonian justification. I'm not going to too much details, but this is an interesting like kind of axiomatic questions for mathematics, for mathematicians. Like we had a few statistical error analyses that are only empirical, only empirical so far. But it would be nice to have other kind of statistical error analysis. I guess one thing that's related, I should have put it just underneath, is better estimate uncertainties. Given that these uncertainties are actually used in the sequel of the Tournesol pipeline, so that's interesting. Like intuitively, if someone only gave one comparison, we should not like consider that what's learned from this single comparison is the final truth, and we should consider that there's a lot of uncertainty on this, and as a result, the contributor should not affect too much the score of the video. So that's already kind of what we're doing, but I think there's a room for a lot of improvement on this. So another challenge is called active learning. So when you're eliciting preferences from an individual, you can ask them, give them a long form with a lot of comparisons to be made or lots of questions. But ideally, you would not. Like people are very lazy. It's already amazing that they're contributing to Tournesol. It would be good to be efficient in the way we are querying them and asking them to contribute to Tournesol. Another thing that we are looking into is to have direct assessments, like in addition to comparison, maybe someone can also like and dislike, and this would be an effortless way to give give assessments on a lot of videos that are noisy, not extremely reliable, but you get more data. That's kind of the idea. I think the nice trade-off. And but then we need algorithms to combine both kind of assessments, so direct assessments and comparisons. And we are looking into how to do this while preserving some of the properties I've discussed previously. I think this is, I mean, we are making progress on this, especially Oscar is going to work on this. Another challenge is to design a noise tunable GBT variant. So right now, maybe this is a bit technical, so I won't go too much into details, but essentially you would want to model the fact that different contributors have more or less noise in the way they input scores. And currently with GBT is not handled quite well. There's some weird phenomenon going on right now with our current algorithm. We call the Camp effect, l'effet de peigne. Yeah, so this is something that is misunderstood right now by both practitioners and theoreticians on the project, so this should be sorted out. And finally, a last thing is volition learning, which is like making the difference for a single contributor between the judgments that they made with a lot of like thoughtful thinking and reasoning, as opposed to the hurried assessments that they made, the comparisons they made very quickly, and they may regret if they came back on this. Yeah, so I think there's both more noise when you're doing fast assessments as opposed to thoughtful volition. So volition is more like thoughtful, and preferences, instinctive preferences are more like, I think there's more noise, but there may also, and that's one issue, but I think more importantly, there may be some biases. Like maybe you systematically prefer some kind of content over others. Actually, there's a video by Economate that showed that essentially people are more racist, if I remember correctly the video, like something like this, I think it was racist, if they are if they don't have a lot of time to think, essentially. And they get more into less racist judgments if they take the time to think. And I think we should investigate at least whether there are differences in our data regarding this, and whether we should learn one rather than the other. And also, like, can we get the user to validate that they prefer what we learn in terms of volition rather than what we learn if we don't make the difference between volitions and preferences? Yeah, this raises a lot of questions. So then the next step is individual score scaling. So this is the this is a problem that we that's a bit older, like this a year ago, yeah, a year and a half ago, that we worked out with Youssef and Oscar, where we looked into this idea of robust parse voting. So the issue is, I like to characterize this as the Parisian and the Marseillais problem. So the Parisian is the guy who's always unhappy and always critical of everything. And the issue is that if content is only scored by Parisian people, it may be badly scored, not because the content is bad itself, but just because it attracted people who tend to be very critical. And so that's a bias that we ideally should correct. And the other issue is what I call the Marseillais problem. Like, if a let's say you have these contributors that always exaggerate, that always push extremely wide judgments, then the content that is only scored by Marseillais people and that is good will be assessed as extremely good. Not because it is extremely good, but just because the kind of persons who score this content tend to like to exaggerate their preferences. Now, again, there are so essentially we've solved this issue sort of with the robust parse voting. I wouldn't say we've really solved it, but at least we had a first step. But there are a few issues with this, if I'm being honest, so hopefully the reviewers won't be seeing this video. For one thing, like 2J scaling on Tournesol is not really working in a sense, because for security reasons, we don't enable a lot of scaling, because if you scale completely, if you enable, no, I won't go into too much details, it's a bit long to explain, but essentially like the constraints we have in terms of security impose that the scaling does not work really. So that's a bit unsatisfactory and it should be sorted out. more generally, like our paper, so the robust sparse voting paper, has a definition of good scaling that really refers actually to the case of consensual preferences. So if everyone agrees, then it's easy to define what a good scaling is because it's the one that matches all of the scales of all of the scores. But if people have different preferences, then it's not clear what it means to scale appropriately the scores of two individuals. And in particular, in the case of Tournesol, for instance, you might want to, like the correlation would be one metric, but maybe you particularly care about the good videos because the bad videos are bad anyways. And it's okay if you disagree with the scaling is not right for the bad videos, but maybe it's more critical if the scaling is not right for the good videos. I mean, this is like borderline philosophy and mathematics, but it should be, I mean, it's worth thinking about. Another open question, which is more mathematical, is what if we let the users optimize their scaling? So we don't compute the scaling of the scores for them. We do it. We let them optimize their scaling. Actually, we will do it for them eventually, but for most users. But what if we think of this in a strategic proofness manner? And so this, I think, raises questions that have never been really asked before, at least to my knowledge. And I think these are really nice questions, especially given that it's. Yeah, I'm not going to go too much details. I think I'm already taking a lot of time. So the next step is like once everybody's scores is scaled, then you want to aggregate all of the scores of different people on different videos. And so the way we do this is using something we call QRMed. So that's what was written on the previous slide. So I'm going to explain it. So essentially the idea of QRMed is, so I like to explain this with crawfishes. So like say you have 5 voters here with the different preferred scores for a video. Then I'm hearing someone. Tilam is making. Then the issue is, then the idea of QRMed is that instead of taking the average, which is absolutely not secure or strategy proof, the idea of QRMed is to make sure that everyone is pulling on the video with a unit force. So typically in this setting, the score of the video here, you would have 4 crawfishes that pull towards the right and 1 crawfish that pulls towards the left. So if you do this, then you would move the score of the video towards the right. So in this situation here, you have 3 crawfishes that pull towards the left, 2 towards the right, and so it will move towards the left. And so you have this one equilibrium, and those who know about this or who are quick to figure it out among you might recognize this value as the median of all of the scores. And in the median, you have half of the people that pull on one direction, half of the on the other direction, so it's the equilibrium. And now the idea of quadratic regularized median is to add a quadratic regularizer, so this comes as a parabolic valley. And the advantage of doing this is that even if you have all of the voters that push in one direction, but they are actually malicious, then they cannot pull completely the score of the video away. And this is something very critical on Tournesol, as most content on Tournesol is not rated by anyone. So if someone controls a few accounts on Tournesol, then they can really control the score of the video, but they can be the only one scoring a video if they take a random video on YouTube. And this creates a vulnerability because you don't want this to be controlling the score of the video. And so the trick of this parabolic valley is to limit the capability of malicious people to pull too far the score of the video if they have limited voting rights. So there are, again, some future work regarding this. So there's this issue of asymmetric uncertainties. I'm not going to go into the details, but essentially it's a prerequisite for the second, which is guaranteeing that if you like a content, it cannot harm the video. It cannot decrease the score of the video. Because essentially you're only giving a positive signal. So intuitively the score of video should not be able to decrease based on this. And I think there's a nice way to solve this using asymmetric uncertainties. but I'm not going to go too much into this. Another nice thing that we did this summer is to work on presumptions. So this is some thoughts that we're having more general thoughts about presumptions, with trying to have a pluridisciplinary approach about this again with philosophers and lawyers and law researchers. I think there's a lot to uncover about presumptions. I think presumptions are everywhere in our society and we don't recognize this, and this is a source of a lot of issue. And in any case, on Tournesol, we've hard-coded, in a sense, two kinds of presumptions. The first one, I'd say, is the presumption of positivity. Namely, it says that most videos that are quite rated on Tournesol are actually positive, like are not like harmful, or more like positive videos. And so this is explicitly encoded. No, I'm not going into the details of how we go about this, but essentially on Tournesol, 85% of the videos have a positive score. And then the other presumption that we encoded on Tournesol is the presumption of non-recommendability, meaning that a video that has not been evaluated a lot, so presumption is like what happens when you don't know much, then they should be regarded as non-recommendable, and the Tournesol recommendation AI in particular should not be recommending it. So this is now sort of again naturally hard-coded now in our solution, in the fact that by default a video score is equal to 0, but to be recommended you need to exceed some recommendability threshold, which is now 20, and this will require that the video gets evaluated by at least 3 people, 3 contributors, 3 accounts technically. But of course, this is parameterizable. Another future work question here is, which is ongoing. It's ongoing, definitely ongoing. So now with Tournesol, with all of the pipelines so far, we are able to assign to each video a score that represents the quality of the video, that is positive for 85% of the videos, and so on. But what's especially through the extension, what Tournesol is doing is actually sending not videos or scores of videos, it's sending bundles of recommendations. I mean, that's what YouTube does. And it's what fits people's actual usage of the web. So through our extensions, we have to select 4 videos to recommend every time someone opens the youtube.com page and has the Tournesol extension installed. And so the question is, how do you select these 4 videos? I think one way to look at this is that we have different goals. So one of them is intra-bundle diversity. So within a bundle, you don't want there to be 4 videos of Science for All, for instance, even though it's a great channel. You don't want them to be 4 videos on the same event, for instance, on climate change, for instance. Maybe you would want diversity to talk about also war risk, or I don't know, cybersecurity and so on. So that's the intra-bundle diversity, which much of the work so far on this has been done in terms of intra-bundle diversity. But there's another kind of diversity that we want, is inter-bundle diversity. Namely, if a user reloads the YouTube page, the user should not be having the same bundle recommendation bundle. It should be quite different from the previous one. So, and more generally, when different people watch different things, you want to be recommended quite a diversity of videos overall. And then there's a third condition that we've identified recently, is what I would call long-term fairness, namely that 2 videos that have the same score should be somewhat recommended as often, or maybe something like this. So it somehow conflicts. So what's interesting is that it may conflict with the others, but there may be ways to guarantee this in the long term in a very mathematical way. And I think the trick necessarily involves something like control theory. And fortunately, we have a control theorist that got interested in Tournesol recently, namely Matteo Zacchi, and hopefully we'll be making a lot of progress on this thing that Kevin and Rui have started to work on. Another thing is to look at what is the impact on users. So right now, like, we're not even thinking of the end users. Like, it's a whole process that's independent of what the end users want or do or does. So the end user is the one that receive recommendations, but we may want to be thinking to include him in our thoughts. So, and that's actually something that we've been looking at already with a research project with Manuel Ribeiro and Bob West from EPFL. And in particular, the question we ask is whether the use of Tournesol's recommend extension changed people's habits on YouTube. And like, the data have been collected. Hopefully, Manuel will come up with interesting insights soon. Another thing is, I think, to publish and analyze, have a quick overview of Tournesol's data set. Is essentially revamping this first paper that we wrote on Tournesol, where we really stressed the database, not the algorithmic side. And I think the data set is indeed extremely interesting, and we should highlight it. And so it could be a paper submission. I think more and more venues are accepting all sorts of database. And I think this one is particularly interesting because it's a large, secure, and trustworthy database of reliable human judgments. That's really the title. So there are a few nice things that have been uncovered with a quick analysis of the database, which I think should be shared with the scientific community. So, for instance, one of them is it's on the homepage of Tournesol, but it's the fact that actually the most important criterion to determine if a video should be largely recommended, according to our contributors, on our subset of videos, is actually whether it is important. This is an important observation. So the importance of importance is important. Why? Because so much of the discussion of recommended systems right now is not about the importance of the topics, of recommended topics. There's so much of it that's about fake news, and I mean, it's not uninteresting, but like, when it comes to what should be recommended, then like the importance of the topic is like the main criterion here, and it really fits with the argument that the biggest issue with recommender systems is the problem of mute news. And mute news is the important problems that don't get enough attention. It can be climate change, it can be cybersecurity, it can be whatever you want. I think what recommender systems recommend is of particular importance, so I think it should be discussed more. But anyways, the focus on importance should be highlighted, and I think it's an important finding. Quite an old finding, we found it years ago. Another interesting insight so this was from Aidan who did a lot of work, interesting work on this. Another person who did a lot of visualization of Tournesol's data is NatNGS. Produced this graph, for instance, of these images of graphs of video comparisons. So here you have videos on each image that are nodes, and you have an edge between two videos if they have been compared by the user. And what's interesting is you have very different topologies of these kind of graphs, and we don't have yet a good theory of how this impact, like for instance, the efficiency of the DGBT learning, of the learning of the scores of the individuals. So there's I think a lot of interesting research also in combining all of this and studying. This is related to active learning as well, how the comparison graphs affect like the statistical errors of the models. And all in all, that's it. That's kind of like the pipeline. So actually, I've gone further than this pipeline. But essentially, on this pipeline, you can see like the top left is more about this trust and voting rights. And then on the bottom, you have the comparisons that are transformed into scores, and then the voting rights enter to determine both the collaborative scaling and the aggregation of the different contributors' scores into global scores. And then these scores are displayed, and there are still things on the right here, which is like how they are used, in particular how they are used to make recommendations. I want to finish with one last question, which is, I think, the big question. The question that is so big that I'm not sure what it would mean to answer it, but I think it's the most important one in the end, is what do we really expect from collaborative governance? What are, you can maybe come up with criteria of what good collaborative governance is, or you can, if you have a, so this is more like, I guess, a more like deontological, property-based approach. But another approach would be more like defining what would be ideally computed by Tournesol, which is interesting because I guess it's more like, in terms of moral philosophy, would be called moral constructivism, which I think is really the meta-ethics that Tournesol lies in, like defines itself as. Maybe not officially, but like at least intuitively. At least that's how I view it. But then, if you want to reach this goal, you have to estimate how far you are from this goal, and this estimation of how far you are from this goal is a very mathematical one. But it involves a lot of security issues and all of this. So I also I actually prefer the second approach, even though I've worked also a lot with the first approach, especially when designing Mihastan. But yeah, I think there's a lot of thoughts to be had that are really pluridisciplinary, because I think at some point it necessarily involves like especially metaethics, but philosophy in general. There's definitely a lot of psychological questions that enter into play. I think it's impossible to have an effective moral philosophy, especially metaethics system that does not include somehow cognitive biases from humans and stuff like this. So you have to take this into account. Then there's sociological phenomena on top on this that maybe you want to combat, fight, or protect yourselves against. I mean, the bad ones. There are others that are positive that you want to leverage and exploit, like trust, for instance, and trust networks and such like this. And to do all of this in the right way, I think really involve a lot more. This is what like Mehdi and I like to call the fabulous endeavor, the fabulous chantier. And hopefully I've excited you a little bit in this talk into thinking along this term. And this concludes my talk. And if you have any questions, now is the time.
Thanks a lot, Lee.
Thank you for the applause.
It's maybe more a comment, like it's. I mean, I guess you summarized it very well, but like. There is room for a lot of other competence than even the ones you mentioned. Like I think, for instance, from what I come from in my research, many things have been studied in signal processing community, for instance, around the algorithms, and especially you at the end have convex optimization problems, and you can really bridge worlds where these people that have thought about the fundamental aspects in signal processing plus algorithm and no optimization in this setting, they can, I guess, bring new ideas. So it's just one specific example, but there is really room for a lot of different knowledge, more or less technical.
Yeah, definitely, and even if you so like the talk was really aimed for, I guess, more like scholars and researchers from different fields, but we also have all sorts of other needs on Tournesol. So if you have gone to the Tournesol's homepage, or you're using the extension, you know that we are currently in great need of fundings. And so if you have a lot of money, or if you want to help in helping if you want to help us find money, answer grants and so on, then this is a very valuable skills for us. Communication, internal, coordinating more and more of this research. This is all very appreciated.
If you have any question or comment more generally.
No more comments. People are already working on finding solutions to the problems.
I'm sorry, I am a bit tired. I just wanted to say thank you for using Jitsi so that I can come back slowly, little by little. Discord is not very helpful to come back to Tournesol.
Yeah, as I said, I might move to Infomaniac. But yeah.
I mean, if no more comments, I guess we can stop the stream. So thanks a lot again, Lei.